Okay, in this video I will go through the solution to the differential equation dy dx is equal to y over 8 times 6 minus y with the initial condition 0, 8. Now this is a logistic differential equation. We can tell that by the two y factors. The differential equation will be 0 when y is 0 and when y is 6. Y equals 6 is the carrying capacity of this differential equation, or of this population system. So to do this, we're going to need separation of variables and partial fraction decomposition. So I'm going to first divide both sides by y times 6 minus y, and leave the 1 over 8 on the other side. We're going to integrate both sides with respect to x. When we do that, the dx's on the left side will cancel. We end up with integral 1 over y times 6 minus y dy is equal to 1/8 integral dx. Now to solve the integral on the left side, we're going to need to use partial fraction decomposition. So we would have 1 over y times 6 minus y is equal to a over y plus b over 6 minus y. Multiplying both sides through by y times 6 minus y, we get that 1 is equal to the y's cancel, so we'd get 6 minus y times a plus by, and when we let y equal 0 in this case, we would end up with 1 is equal to 6a, implying that a is equal to 1 over 6. When we let y equal 6, we get that 1 is equal to 6b, implying that b is also equal to 1/6. Now it's typical that those numbers a and b will come out to be the same thing, and we're going to bring those all the way outside. So 1 over 6 times the integral of 1 over y plus 1 over 6 minus y dy. I'll just go ahead and perform that integration there. It's 1 over 8x plus c. Now when we do the integral on the left side, it's important to note that 1 over y is simply natural log of the absolute value of x. However, the integral of 1 over 6 minus y, because there's a negative y in the denominator, if I did a u substitution with u equals 6 minus y, you would see that it would come out to be negative natural log of the absolute value of 6 minus y. And I won't go through that whole process. And that's all times 1/6 is equal to 1/8 x plus c. Now often what is done is you'll always have the positive and the negative in here because of the 6 minus y. It's typical of the logistic differential equation. Is I'm going to factor out a negative so that I get negative 1/6, and instead we'll write this as natural log of 6 minus y times the natural log of, sorry, that's not x above that, it should be y. So it's negative 1/6 times the quantity natural log of 6 minus y minus the natural log of y, again, is equal to 1/8 x plus c. By doing that, we can use the properties of logarithms now to rewrite that as negative 1/6 times the natural log of absolute value of 6 minus y over y, again still equal to 1/8 x plus c. And if I multiply through both sides by negative 6, I will get natural log of absolute value of 6 minus y over y is equal to negative 6/8, which we'll write as negative 3/4 x plus c. And I'm going to exponentiate both sides. And when I do that, I end up with absolute value of 6 minus y over y is equal to, recall that multiplying two numbers with the same base, we add exponents. So when I see the added exponents, I can rewrite that as e to the c times e to the negative 3/4. And e to the c is just a constant. So after I take away the absolute value, I will add the plus or minus to the other side. Negative 3/4. And I can take out the whole plus or minus e to the c and simply replace that with c. So that is really just c times e to the negative 3/4. Now, on the left side, I'm going to split this up into 6 over y minus 1, and that's equal to c e to the negative 3/4. When I add to the other side, add the 1 to the other side, I get 6 over y is equal to 1 plus ce to the negative 3/4. And finally, flipping both sides and multiplying through by positive 6, I end up with y is equal to 6 over 1 plus ce to the negative 3/4. At this point, I'm going to use the initial condition, which was that x is equal to, and sorry, I have to go all the way back to when I started over here. This is negative 3/4 x, negative 3/4 x, negative 3/4 x, negative 3/4 x, and that's negative 3/4 x there. So when I apply the initial condition that x is equal to 0, then I end up with y is equal to 8. I get 8 is equal to 6 over 1 plus c, or 8 plus 8c is equal to 6. 8c is equal to negative 2. C is equal to negative 1/4. And so we're ready to wrap that up. And we get y is equal to 6 over 1 minus 0.25 e to the negative 0.75 x. And so that would be the solution to this differential equation, to the logistic differential equation. All right, we'll stop this at this point then.